guys! So in today's lesson, you're going to see how proportions relate to making decisions in art, design, and even magazine layouts. As you can see, we have the key idea, similar figures. Figures that have the same shape, but not necessarily the same size are called similar figures. And we can notice that these are two triangles, triangle ABC and triangle DEF, two, same shape, but they are not the same size. Triangle ABC is smaller than triangle DEF. And how can we tell whether two figures are similar? These two bullets you have to make sure that these two bullets are satisfied. So the first bullet is corresponding side lengths are proportional. And the second one is corresponding angles are congruent. So what that means, we can talk a little bit about that. Corresponding side lengths, meaning, let's say we've done this before, but AB, what's corresponding to AB is DE in this triangle, right? So I'm going to set up a proportion, AB over DE. Does that equal BC? The corresponding side length of BC is EF, EF. So so if you can set that to proportional, equal to each other, does that equal to one another? So if it does, that's one check. The second bullet, corresponding angles are congruent. All of your angles, so for example, angle B is corresponding to angle E. So are they congruent? And corresponding angles with C and F, and then A and D, are they all congruent? And these arcs, you see how there is single arc, and then there's double, and then there's triple. Those represent, the corresponding angles. And one more thing to point out from this slide is that congruent symbol looks like that with the wave and the equal. And then the similar symbol is just one way without the equal sign. So let's look at an example together. Which rectangle is similar to rectangle A? So rectangle A is here, and then we have B and C, and we're given all these dimensions. Since we know that each figure is a rectangle, so all of the three are rectangles, their corresponding angles are the same, are congruent. They're all 90-degree angles, so that bullet is checked. We need to check to see if corresponding side lengths of each rectangle, are proportional to see which rectangle is similar to rectangle A. So that's what we're going to do. So let's compare rectangle A and rectangle B first. We're going to compare the side lengths and the width. Let's first start with the length. So length of A, right? Length of A, which is 6, and then length of B. So length of A is 6 over length of B is 6 again, equals 6 over 6 is 1. Then we're going to compare the width. Width of A, 3. Over width of B is 2, and we can't simplify that any further, so we're just going to leave it as 3 over 2. So these two are not proportional because 1 and 3 over 2 is not same. They're not the same. So right then and there, rectangle A and B are not similar to each other. Let's compare rectangle A and rectangle C. Again, same thing, length of A is 6 over length of C is 4. And you can reduce that, simplify always, to 3 over 2. So that's the ratio. And width of A is 3 over width of C is 2, and we can't reduce, but we got the same, and they are proportional. Therefore, rectangle C is similar to rectangle A. And notice rectangle A is bigger than rectangle C, but being similar doesn't mean that the size has to be the same. Let's look at question number 2. The triangles are similar, find X. So two triangles are similar, and we have to find X. And I'm highlighting similar because I want to tell you that now the two bullets are satisfied in this question because the given is that these two triangles are similar. So we can automatically just set up a proportion. Since the triangles are similar, corresponding side lengths are proportional. So it goes hand in hand. So let's compare the side length. 6 from the smaller triangle over the corresponding side length is 9. So over 9 is equal to 8. We're going to go back to the smaller triangle over, we don't know, so we're going to call it x. Now we've done this before in the previous lesson. We're going to cross multiply. Then we get 6x is equal to 72 because we have 8 times 9, 9 times 8. Then we want to get x, find x, right? That's the question. We want to get x alone. So we're going to divide both sides by 6. 6 crosses out and you get x is equal to 12 meters. And that's the final answer. Our last question of this lesson. An artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in the replica is 3.75 inches. What is the height h of the trapezoid in the replica? So we have two drawings on the side. One is the painting and one is the replica, the copy. And we were given that the two trapezoids are similar and that we have to find the height in h. So right here, the height of the replica. So given that these two are similar, we can set up the proportion. So I'm going to go from replica to painting, replica to painting. So 3.75, what's the corresponding side length of 3.75? 15 over 15 is equal to, we have h, that's what we're looking for, over 12. We're going to cross multiply. We get 15h is equal to 3.75 times 12. 15h is equal to 45. I'm going to divide both sides by 15 because I want h by itself. 15 cancels each other out, or it becomes 1. So h is equal to 3 inches. So the height of the trapezoid in the replica right here is 3 inches. And that's it for today. And I hope this video made sense. And if it doesn't, make sure that you reach out to me. And thanks for watching. Bye.